Hey there, AFDA. Mr. Kimble here. Today we're going through the Unit 8 Lesson 5 notes where we talk about factorial notation. Okay, the way that we write factorial notation is using an exclamation point. So that N exclamation point represents N factorial, not N. You get it? Because it's like I'm saying N really loudly because of the exclamation point. So in math, when you see an exclamation point behind a number, it's N factorial, or whatever number it is, factorial. And factorial just means that you multiply all the numbers from whatever that number is all the way down to 1. Okay, so when you have an exclamation point behind a number, that's factorial notation. So it's that number factorial. And that just means you're going to multiply every number, starting with that number, counting down all the way to 1. Okay, so number 1, let's do some examples. 3 exclamation point, that's 3 factorial. And 3 factorial means you multiply, starting with 3, all the way down to 1. So that would be 3 times 2 times 1, which is 6. So 3 factorial equals 6. 6 factorial means we start with 6 and we multiply from 6, counting down all the way to 1. So that's 6 times 5 times 4 times 3 times 2 times 1. And we get 30, 120 times 6, 720. Okay. 0 factorial, as a rule, 0 factorial always equals 1. So 0 factorial, it just has to equal 1. Okay, and we'll actually see why in our next notes video, why 0 factorial has to equal 1. All right, so it's really easy when it's just a number. What if we have a fraction? 8 factorial over 6 factorial. Okay. I'm going to show you a couple ways to do this, but the way that I would like you to do it means you're going to have to multiply less. All right. So you could figure out what 8 factorial equals. Okay. You could say, okay, 8 factorial means on top of that fraction, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But that's going to equal a really big number. We got 8 factorial. If we multiply all those numbers together, we get, what do we get? 40,320. Divided by, on the bottom, 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. We just did 6 factorial a minute ago. It's 720. And then if we do 40,320 divided by 720, we get our answer, which is 56. But that's a lot of multiplying in the calculator, a lot of typing in numbers. Okay? When you have a fraction with factorial, what I want you to do is look for numbers on the top and the bottom that will cancel each other out. When you have a fraction, if you have the same number on the top and the bottom, they will cancel each other out. So when I look at my 8 factorial over 6 factorial, what numbers do I have on the top and the bottom? Well, I have 6 on the top and the bottom. So the 6 on top will cancel out the 6 on the bottom. The 5 on top will cancel out the 5 on the bottom. The 4 on top will cancel out the 4 on the bottom. The 3 on top will cancel out the 3 on the bottom, the 2's will cancel out, and the 1's will cancel out. And all we're left with is 8 times 7, and 8 times 7 is 56. So it's a simpler way of getting to that answer without having to multiply all of those numbers together. Because when you start to get bigger numbers with factorial, they get bigger really quickly. Okay? You saw 6 factorial was only 720. By the time we go to 8 factorial, it's already over 40,000. Okay? So if you look at problem number 5, 12 factorial divided by 9 factorial, that 12 factorial is going to be an enormous number. 9 factorial is going to be really big in its own right. And then you have to divide those really big numbers. So the way that I would do it is Think 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we can cancel out. Any number that's the same on the top and the bottom cancels out. So the 9s cancel, the 8s cancel, the 7s, the 6s, the 5s, the 4s, the 3s, the 2s, and the 1s. And all we're left with is 12 times 11 times 10, which is 1,320. Now, you might say, Mr. Kimble, that's a lot to write. I don't want to write all that stuff. And I don't think you need to write all of that either, okay? What I normally do if I'm writing this is I always use the smaller number to cancel out the bigger number. So when I see 12 factorial over 9 factorial, I'm going to use that 9 factorial to cancel out as much as the 12 as I can. And that 9 will cancel out everything from the 9 all the way down to 1, leaving me with just 12, 11, and 10. And then again, multiply those together, there's our 1,320. So we don't have to write all of those numbers to cancel out if we can think about which ones cancel out and then what numbers then would be left. All right, number 6, we got 7 factorial divided by 9 factorial. This time my bigger number's on the bottom. That's fine. Okay. I'm going to use my smaller factorial, the 7 factorial, to cancel out as much of the bigger one, the 9, as I can. And that 7 factorial will cancel out everything on the bottom from 7 down to 1. So again, if I wanted to write it out the long way, I would say 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, 9 factorial, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And then I would look to cancel out, right? The 7s cancel, the 6s, the 5s, the 4s, the 3s, the 2s, and the 1s, leaving me with just 9 and 8 on the bottom. 9 times 8 is 72. There's nothing left on top, which really means it's a 1 on top. So my answer is 1 over 72. But again, I wouldn't really write all of that out. What I would do is say that 7 factorial on top cancels out everything in the 9 factorial from 7 down to 1, leaving me with 9 and 8. Because there's nothing left on top, it's really a 1 left on top, and 1 over 9 times 8 becomes 1 over 72, and I'm not having to write out all of those numbers. Okay? Then what about a fraction like this where we have 2 factorials on the bottom? So what I'm going to do is use one of those factorials to cancel out as much of the top as I can. So I'm going to cancel out that first 4 factorial. Let me write this a little bigger. 8 factorial over 4 factorial times 4 factorial. So what I'm going to do is use the 4 factorial to cancel out as much of that 8 as I can. And it's going to cancel out everything in that 8 from 4 down to 1, leaving me with 8, 7, 6, and 5 left on top, divided by, on the bottom, 4 factorial really means 4 times 3 times 2 times 1. Now, instead of multiplying, I'm going to try to cancel out some more. So what I'm doing is looking for numbers on the bottom that go into numbers on top. Well, 4 goes into 8 twice. So the 4 will cancel out, and 8 divided by 4 is 2. So that 8 just turns into a 2. What number on top does 3 go into? Well, 3 goes into 6. 3 goes into 6 2 times. So the 3 will cancel out, and 3 goes into 6 2 times. All right? What number on top does 2 go into? Well, 2 doesn't go into 5. It doesn't go into 7, but this 2 on the bottom could cancel out one of those 2's that we have, either the 2 on top of the 8 or the 2 on top of the 6. So this 2 on the bottom cancels out one of those 2's on top. And then 1 doesn't really matter, okay, because dividing by 1 doesn't change anything. So what am I left with? Well, on top, I still have a 7, a 2, and a 5. On the bottom, I don't have anything left over. So then my answer is just 7 times 2 times 5, which is 70. So when you have multiple factorials, use one to cancel out as much of the bigger factorial as you can. Then write what's left and then look to cancel out some more before you get your answer. So let's see some more like that. So we got 12 factorial divided by 5 factorial times 7 factorial. I'm going to write it a little bigger. 12 factorial divided by 5 factorial times 7 factorial. Of those 2 factorials on the bottom, I would use the bigger one to cancel out as much as possible on top as I can. So I'm going to use that 7 factorial to cancel out everything on top from 7 down to 1. That leaves me on top with 12, 11, 10, 9, 8, and then again 7 down to 1 got canceled out by that 7 factorial on the bottom. But I still have this 5 factorial left on the bottom, so I'm going to write that out. 5 factorial means we start with 5 and we multiply all the numbers all the way down to 1. Then what I'm going to do is look for numbers on the bottom and see if there are any numbers on the top that those numbers go into. So I start with 5. Are there any numbers on top that 5 goes into? Yeah, 5 goes into 10. So the 5 cancels out and 5 goes into 10 2 times. All right, what about 4? Does 4 go into any of those numbers on top? Yeah, 4 can go into 12 and it can go into 8. It doesn't matter which one you pick. I normally like trying to get rid of the bigger numbers. So I would say the 4 goes into the 12 3 times. So the 4 cancels out. And when I do 12 divided by 4, I get 3. Then 3. Does 3 go into any numbers on top? Well, I could use the 3 to either cancel out the 3 on top of the 12, or I could say 3 goes into this 9. It doesn't matter which one. Here I might use it to cancel out the 3. So that 3 on the bottom will cancel out that 3 on top. All right, does 2 go into any of those numbers? Well, that 2 could either cancel out the 2 on top of the 10, or it could go into 8. It doesn't matter which one. Okay, I'm going to use it to cancel out the 2 on top. And then again, 1 doesn't really matter because dividing by 1 doesn't change anything. So now everything on the bottom's canceled out. And what am I left with on top? Well, I'm left with 11 times 9 times 8. So we do 720 and 72, 792. 11 times 9 times 8, so that equals 792. All right, one more together before I give you some on your own. What's 18 factorial divided by 12 factorial times 6 factorial? I'm going to write it a little bigger. So 18 factorial divided by 12 factorial times 6 factorial. Again, if I have multiple factorials, I'm going to use the bigger one to cancel out as much of that number on top as I can. So I'm going to use this 12 factorial to cancel out everything in that 18 factorial from 12 all the way down to 1. So that's still going to leave me with the 18, the 17, the 16, the 15, the 14, and the 13. But again, 12 all the way down to 1 got canceled out by the 12 all the way down to 1 on the bottom. But I've still got this 6 factorial on the bottom, so let me write that out. That's 6 times 5 times 4 times 3 times 2 times 1. Now I'm looking here to see what else I can cancel out. So again, I'm going to look at each of those numbers on the bottom and see if there are any numbers on top that that number goes into. So 6. Are there any numbers on top that 6 goes into? Yeah, 6 goes into 18. So the 6 will cancel out, and then I do 18 divided by 6, which is 3. All right, then I got the 5. Are there any numbers on top that 5 goes into? Well, 5 goes into 15. So I'm going to cancel out the 5, and 15 divided by 5 is 3. So the 15 is now a 3. All right, what about 4? Are there any numbers on top that 4 goes into? Yeah, 4 goes into 16. So I'm going to cancel out the 4 on the bottom. And on top, 16 divided by 4 is 4. All right, 3. Are there any numbers on top that 3 goes into? Well, 3 doesn't go into 17, 14, or 13. But I could use that 3 to cancel out the 3 either on top of the 18 or the 3 on top of the 15. So this 3 on the bottom will cancel out a 3 on top. 2, I could say 2 goes into 14, or I could say 2 goes into that 4 that's over top of the 16. It doesn't matter which one. I'm going to use the 14 this time. So 2 cancels out, and then 2 goes into 14. 14 divided by 2 is 7. and then 1 doesn't really matter. So what am I left with here? Well, I'm left with, on top, I've got a 17, a 4, a 3, a 7, and a 13. And to get my answer, I just multiply those 5 numbers together. So 17 times 4 times 3 times 7 times 13 comes out to be 18,564. And simplifying fractions with a factorial notation is kind of where we're heading next class, okay? So it's going to be really helpful if you're able to do this problem. And again, if I tried to figure out what these numbers equal, 18 factorial is an enormous number, okay? So it's easier just to break it down before I multiply instead of having to multiply these enormous numbers, all right? So we got some problems for you to try. So what I would do is pause the video. So we got 10 through 16. What I would do is pause the video, try these problems on your own, then hit play and make sure you're able to get them correct. So te toca a ti simplify each expression. All right, number 10, 10 factorial. So there's no fraction here. There's nothing to cancel out. So 10 factorial just means I'm multiplying all of the numbers starting with 10, going all the way down to 1. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We multiply those together. And we get 3,628,800 as our answer. So again, factorial notation gets really big really fast. All right? So if 10 factorial is already over 3 million, 20 factorial and 15 factorial are going to be even bigger. Okay? So here's where having a fraction and looking to cancel stuff out is going to be really helpful. Let me rewrite it first. So it's a little bigger, 20 factorial divided by 15 factorial. So my bigger factorial is on top. So what I would do is use the factorial on the bottom to cancel out as much on top as you can. All right, so this 15 factorial is going to cancel out everything on top from 15 down to 1, which would leave me with the 20, the 19, the 18, the 17, and the 16. Because again, everything from 15 down to 1 got canceled out by the 15 factorial that's on the bottom. Because there's nothing left on the bottom, my answer isn't a fraction. It's just going to be what I get when I multiply those numbers together. So now we just need to multiply 20 times 19 times 18 times 17 times 16, and we get 1,860,480. So again, those numbers get really big really fast when we're talking about factorial notation. Number 12, doing 281 factorial divided by 279 factorial. Again, those are both enormous numbers, probably too many digits for your calculator to deal with, okay? But again, because it's a fraction, we can cancel stuff out, and our answer isn't quite so bad, okay? Again, use the smaller one to cancel out as much of the bigger one as possible, okay? So we can use that 279 factorial to cancel out everything on top from 279 all the way down to 1. Well, what would that leave me with on top? Well, it would leave me with 281 and 280. Again, starting with 279 all the way down to 1 got canceled out by that 279 factorial on the bottom. There's nothing left on the bottom, so my answer is not a fraction. It's just what I get when I multiply 281 times 280, which comes out to equal 78,680. All right, number 13. Number 13, our bigger factorial is on the bottom. So that means we're going to end up with a fraction, right? Because we're going to have stuff left over on the bottom. Again, these are both enormous numbers. So instead of trying to figure them out and then divide, cancel out as much as you can. That's 74 factorial. We'll cancel out everything on the bottom from 74 all the way down to 1. Well, what would that leave left over on the bottom? Just 75, right? On the bottom, 75 factorial is 75 times 74 times 73 times 72, all the way down to 1. But that 74 factorial on top canceled out 74 down to 1, so the only thing left on the bottom is 75. Because there's nothing left on top, we would just say it's a 1 left on top, so my answer is 1 over 75. All right, starting with 14, we've got problems where you've got more than 1 factorial on the bottom to cancel out what you have on top. So 14 factorial divided by 4 factorial times 10 factorial. Again here, what I would do is use the bigger factorial on the bottom to cancel out as much of the biggest factorial on top as possible. So that 10 factorial will cancel out everything on top from 10 all the way down to 1. So what's going to be left on top? Well, 14, 13, 12, and 11. Because 10 all the way down to 1 got canceled out by the 10 factorial on the bottom. But we're not done because we still have 4 factorial on the bottom. So that I'm going to write out. 4 times 3 times 2 times 1. And then what I'm going to do is look for numbers on the bottom that go into numbers on the top so I can simplify it some more. Does 4 go into any of the numbers on top? Yeah, 4 goes into 12. So the 4 cancels out and I divide. 12 divided by 4 leaves me with a 3. All right, then 3. Does 3 go into any of the numbers on top? Well, 3 doesn't go into 14 or 13 or 11. But 3 does go into that 3 that we have now on top of the 12. So that 3 will cancel out the 3 that's on top. All right, does 2 go into any of the numbers on top? Well, the only numbers I have left are 14, 13, and 11, and 2 will go into 14. So I cancel out the 2, and then 14 divided by 2 is 7. And then 1 doesn't do anything because dividing by 1 doesn't change my answer. So our answer then is whatever's left on top. So we've got 7 times 13 times 11. So I multiply 7 times 13 times 11, and I get 1001. All right, 15. We've got 9 factorial over 3 factorial times 4 factorial. I'm going to write it a little bigger. 9 factorial over 3 factorial times 4 factorial. Again, when you have multiple smaller factorials, I would use the bigger one to cancel out as much on top as you possibly can. Okay, so that 4 factorial is going to cancel out everything on top from 4 down to 1. So what's going to be left on top? Well, a 9, an 8, a 7, a 6, and a 5. Because the 4 factorial, like 4 all the way down to 1, got canceled out by that 4 factorial on the bottom. But we're not done because we still have this 3 factorial on the bottom. 3 times 2 times 1. Okay? So again, we're looking for stuff that will cancel out. So 3, does 3 go into any of the numbers on top? Yeah, 3 goes into 9. So the 3 will cancel out, and 9 divided by 3 is now just 3. Does 2 go into any of the numbers on top? Yeah, it can go into 8 or 6. It doesn't matter which one you choose, but you can only do it with one, not with both. So I'm going to say the 8. So the 2 cancels out, and 8 divided by 2 is 4. And then the 1 doesn't really matter, so we can just cancel that out. So what are we left with on top? Well, we've got a 3, a 4, a 7, a 6, and a 5. So we multiply 3 times 4 times 7 times 6 times 5, and we get 2,520. The last one, we got 15 factorial divided by 6 factorial times 9 factorial. Let me rewrite it, make it a little bigger. Again, when you have multiple factorials, I would use the bigger factorial to cancel out as much as possible. Okay, so I would use this 9 factorial to cancel out as much of that 15 factorial as I can. And it would cancel out everything from from 9 all the way down to 1. So what would be left on top? Well, I would have 15, 14, 13, 12, 11, and 10. Everything after that, the 9 down to 1, is going to be canceled out by the 9 factorial on the bottom. But we're not done because I still have something left on the bottom. I have that 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Then again, what I would do is now look at those numbers on the bottom and see if there are any numbers on top that they go into. So I start with 6. Does 6 go into any of the numbers on top? Yeah, 6 goes into 12. So I cancel out the 6, and 12 divided by 6, that 12 is now just a 2. Does 15 go into any of the numbers on top? Yeah, or excuse me, does 5 go into any of the numbers on top? Yeah, it goes into 15 or 10. All right, it doesn't matter which one I choose, just pick one. I like getting rid of those bigger numbers, so I'm going to use the 15. So the 5 cancels out, and 15 divided by 5 is 3. Does 4 go into any number on top? Now, there are no numbers left that 4 goes into. But if I think 4 is really 2 times 2, I can cancel those out separately. So this 2 could go into 14. So 2 goes into 14 7 times. And this 2 could go into 10. 10 divided by 2 is 5. So I cancel out the 4 by breaking it down and then saying, okay, that 2 goes into that number and that 2 goes into that number. All right, what about 3? Well, 3 doesn't go into anything except for the 3 that's now on top of the 15. So this 3 on the bottom cancels out, and 3 divided by 3 is 1, which means that 3 on top also cancels out. All right, then 2 doesn't go into 7 or 13 or 11 or 5, but I can use this 2 on the bottom to cancel out that 2 on top of the 12. So those cancel out, and then 1 doesn't really matter. So what am I left with? Well, on top I have a 7, I have a 13, and I have an 11. 7 times 13 times 11 comes out to be 1001. All right, that's it for today. If you have any questions, be sure to jot them down so the next time we meet, you can be sure to ask. I appreciate you taking the time to watch the video. Have a wonderful day.